A flu epidemic approximately follows the curve p equals 150 over 1 plus 50,000 e to the negative 0.35 t million people, where p is the number of people infected, million people, and t is the number of weeks after the start of the epidemic. How fast is the epidemic growing? That is, how many new cases are there each week after 20 weeks, after 30 weeks, and after 40 weeks? Round your answer to two significant digits. The question, how fast, requires that we find the derivative. This function represents the number of people infected after t weeks. Observe that this is a quotient. We have the top and the bottom. However, we will rewrite this as 150 times 1 plus 50,000 e to the negative 0.35 t raised to the negative 1 power. There is a function inside the exponential function and inside the power function, power negative 1. So we will use the chain rule a few times. P prime, or dp dt, 150 is a constant multiple, so we would rewrite this. The next function is the power function with the power negative 1. So we bring down the negative 1 power and we lower the power by 1. Negative 1 minus 1 gives us negative 2 in the power. We always rewrite the inner function first. So the inside of the power negative 2 is 1 plus 50,000 e to the negative 0.35 t. And then we multiply the derivative of this function. The derivative of 1 is 0 plus 50,000 now is a constant multiple, so we would rewrite it 50,000. The derivative of e to the anything is e to the same thing, so e to the negative 0.35 t. Negative 0.35 t is the function inside the exponential function, so we would need to multiply its derivative, which is negative 0.35. This is dp dt. If we simplify this, then we take 150 times negative 1 times negative 0.35, which will give us positive 52.5. With the negative 2 power, we will bring this factor to the denominator and make it a positive 2 power. Inside the power is 1 plus 50,000 e to the negative 0.35 t. We still have 50,000 e to the negative 0.35 t in the numerator. We then evaluate this expression when t equals 20. Everywhere we see t, we would replace t with 20. So this is 52.5, 50,000 e to the negative 0.35 times 20 in the numerator. In the denominator, 1 plus 50,000 e to the negative 0.35 times 20. Don't forget to raise it to the 2 power. Put this in a calculator, we will get 1.10257 rounded to 1.10. This is the number of people in million, and so million people per week. What this means is that after 20 weeks, the number of people who was infected is about 1.1 million people each additional week. For 30, we do the same thing, but this time we plugged in 30. This is 52.5 times 50,000 e to the negative 0.35 times 30 over 1 plus 50,000 e to the negative 0.35 times 30. Don't forget to square this. Put this in a calculator, we will get 12.7951, which will round it to 12.80. The unit is million people per week. It is still the same rate, but this rate only is for 30 weeks after. We say that after 30 weeks, the number of people who were infected was 12.8 million people for each additional week per week. When t equals 40, dp dt evaluated when t equals 40 is 52.5 times 50,000 e to the negative 0.35 times 40 over 1 plus 50,000 e to the negative 0.35 times 40. Don't forget to square this. Put in a calculator, we will get 2.01198, which will round it to 2.01 million people per week. We interpret this as after 40 weeks, the number of people who were infected with the flu is 2.01 million people per week. Notice that after 20 weeks, go to 30 weeks, the number of people who were infected was increasing, but then going from 30 to 40, the number of new cases are decreasing. This is the nature of the epidemic. It increases, then decreases, and so on.